biochemistry series. Today we're going to talk about biominerals. So, most ionic compounds are often solid materials. Sodium chloride tables are NaCl. Who's the latter? So here is a structure of the NaCl. So here, so the sodiums are the purple, and the chlorides are the green. So you can see it's a very sort of just cubic shape in which, but the real ones you see, they're much like 100 of these cubics smushed up together, and that is salt in the meantime. Now in the meantime over here, calcium oxide, CaO, is the cement main ingredient, and here, over here in the primer, So if we just go ahead and get the calcium oxide, here's calcium oxide over here, in which is calcium oxide. It's very similar. Ca is for the purples and the O's are the oxygens. Very cubic structure, just like you'd expect. Here's iron oxide. Rust, it's a little bit disoriented. If you chose 3 iron 3 oxide, remember it's the 3 ion. Remember that confusion over here, and here we have it. The oranges for the iron and the red for oxygen. Very complicated structure as I zoom in up over here. It's hard to see the crystal structure. But there's always patterns, and if you just keep looking, you eventually spot a pattern over here. So, do you spot pattern? I do. I spot pattern. 2 irons. Every 2 irons, there are 3 oxygens. So here we go. Let me go ahead and let's see. So here we go. So let me just eliminate a bit of this. So here we have, here is, if we zoom on here, 2 irons, 3. So, and you can see that, so it forms this sort of closed shape. We have titanium dioxide, white pigment plate, though TiO2. Titanium dioxide is toxic. Our organism range of atoms in a solid are called crystals. So here's the titanium dioxide, and we have here, it's very normal. We have this classic TiO2, 1 titanium, 2 oxygens, and that is it. Next slide we have over here is one compounds are held together by charge. Here we go. Calcium oxide, rust. Whoa, that's complicated. And titanium dioxide like this. Oopsies. Carbonic acid, bicarbonate, or carbonate. Carbonic acid can lose 1 or 2 protons and can form a salt with 1 or 2 sodiums. Bicarbonate, I know bicarbonate sounds like bi means 2, but no, that's not what it means. Very confusing. Here I have sodiums in. Sodium bicarbonate baking, so that if you lose here, we get sodium carbonate. And if we lose this, it's just so carbonic acid. Remember this? This is CO2 plus HCH2O3. And baking soda. And this. Now, remember the line making that we had CO2 plus H2O? Well, yes, that is it. Well, it's just one. What is the real formula for calcium carbonate? I'll give you a few moments to ponder this out. Feel free to pause the video. Wow, if we're back, that must mean it's good. -1. Wait a minute. What's there 4 plus? Does not balance. This is the extra one. Remove the thing. This is calcium carbonate. Here's calcium carbonate, also known as calcite. Calcite is made of calcium carbonate. So, if you guys will look here, here is the structure of calcite. Very organized. If you look at it straight from the top, you will find a pattern, but I don't really understand how you look at it through the top. Look, here it is. Carbonic and then calcium carbonate. This is calcite. It's very sort of structured in this neat and organized way. There's this pattern you can clearly see with this view. Okay, so she said calcite is a mineral made of calcium and carbonate, as the name suggests. The close-up view. Class 2, -1 balances. Shells are made of CaCO3. Some sand is made from pieces of shell, but most sand is silica SiO2. Calcium is what that pigment can color starfish exoskeletons. Here we have CaCO3 in the process. And coral. Corals are animals that build protective shells, mainly made of calcite. Another beautiful image. Limestone, indeed, is made from CaCO3. The range of ancient cores and showed emeralds from these rock outcrops. Chalk is made from calcium carbonate. As the range of calcium-containing organisms float upon the sea, they deposit as chalk. Chalk was once part of living seas. So when you have this nice like you're dropping on the chalkboard, it's all from living seas. Marble is a metamorphic rock made of pressurized CaCO2. Even though marble is rock, most marbles are originally made by sea life. Very interesting, isn't it, huh? Right? Yep, it is. Eggshells are made from CaCO3. Calcium carbonate is what that pigment can color eggshells. CaO and CaOH2 are part of the cement making process. After water, cement is most used material by humans. The lime cycle, cement making. Limestone is a natural form of calcium carbonate. The magic reaction begins with calcium carbonate, in which usually it's a form of limestone, but also could be considered. Remember, limestone is made from ancient seashells. You can actually find this on YouTube, like where people make cement, but back to it. When lime can dry off their carbon dioxide, leaving calcium oxide, burnt lime. So, sorry, I accidentally did this. And lime can, we're gonna roast this cement, in which remove this and form calcium oxide, CaO. I hope you remember that. Burnt lime. Then, what we're going to do is we're going to add some H2O. Adding water gives slaked lime, a brittle solid. Calcium hydroxide. Here it is, hydroxide. And then adding more water gives cement mortar, which is poured into blocks or other forms. After drying, currently in there, carbon returns, forming calcium carbonate. Wait. This is what we began with, but it's different. It's because it's been added with water, so that's the difference. Limestone drives out CO2, calcium, and then add water to form mortar, then dry and cure in the air. Wait, there's a thing. Wait. This is funny. Well, it is funny. Now let's talk about phosphoric acid, also known as phosphate. Is triprotic phosphate, sodium phosphate. A lot of scientists use this as an ingredient in their experiments. What about just calcium phosphate? Wait a minute, this is one. I'll give you a few minutes to ponder this out. Feel free to pause the video. Well, we're back. Here's the answer. It's because, 2 plus, but that is the problem. Instead, but then there's this negative problem. Instead, we need this C3PO42. 3 calcium 2 phosphate to create a balance of charge. Whoa. Apatite is a phosphate mineral that makes a bone, but this time we need this. Now, notice the positive and negative charges balance. Sorry, there's a mistake in the presentation. It's supposed to be 10. It's supposed to be 5 calciums, and that's much better. Then, look. What's this? Ooh. Apatite is a form that makes a bone. This image goes from a human tooth sample. Now, let me show you apatite in detail. Here is apatite in this organized structure. Later we're going to do some rendering with it, but here is it. Apatite. If we zoom out a bit and we go ahead and get this entire thing here. Look, if you notice, we have this phosphate over here, the calcium and the hydroxide. Notice the hydroxide in one thing. Later we're going to do some rendering with it. I'm going to make the phosphate mineral. As it is. I'm also going to make the update of phosphate. Antlers. Ooh, teeth. Here we have something called sodium fluoride. The donor electron, we have both of the neon configuration. Why fluoride in toothpaste? Toothpaste contains the salt sodium fluoride. Fluoride toothpaste changes the content of teeth, rising teeth with sodium fluoride acting O2 as F, strengthening the crystal. It changes the formula but not charges of appetite. Since they're both -1. Same thing for hydroxide and fluoride. Well, here we go to the overview, and here we are. Fluorapatite contains some fluorine in place of hydroxide. So, here's the apatite I showed you earlier. This time we're going to do some rendering. So, what we're going to do is we're going to change just the hydroxides into fluorides. So, we're just going to start with this hydroxide. We're just going to click on both of these. Oopsies. Sorry, I accidentally pressed the entire thing. Look, now that we have this selected, we will then go to build. Now, let me just do this 3-button editing. So now we will just go ahead and choose fluorine. And first of all, we're going to click this and this. And then in which we will just then choose the fragment, we choose fluorine in which it is replaced. Okay, and here we go. I'm sorry, but this is just frustrating. Okay, anyways, back. I'll see you later and see you later. Bye for now. And don't forget to subscribe, really important. I'll see you later. Bye for now.